Good morning. Welcome back for the last two sessions. So today what we will be discussing is something that is very relevant for today's society, the privacy and the best practices, how to deal with the breaches. And I must admit here that you have an expert sitting here. She is the most relevant person for this kind of topics, which I will discuss as we go. And then you can take a step forward because there's a number of challenges that are unsolved. So the idea here is that I'll tell you what has been done, and then I'll give you some ideas on what can be done in the future. Okay. All right. So just to recap on this thing, we started looking with the face recognition, and then we said this is a typical case where we have a face detection, and then you have alignment and recognition, feature extraction, comparison, and then there is a database. And then there is a comparison that is coming up, right? So this was the whole idea. And then I told you that as soon as we identify the subject, then we are going to tell that this is a person that we identify, or this is a person that we do not identify or reject. This doesn't work. Okay. All right. So now remember, I told you that the breaches can happen. Yesterday we spoke about attacks. So attacks usually happen at this part or any of the pipeline. So breaches typically they are more concerned with this part, the database part, right? So because whenever we are talking about breaches, we're talking about large scale attacks. We're not talking about one person attacks. Maybe even in one person attacks is fine, but the scale, if you have to have a real big impact, then you're trying to target the database. So one of such attacks is also morphing attack, right? That we discussed today. So we are trying to inject the data, inject the poison into the database by giving a wrong kind of tracing info, manipulative tracing. Okay, so now if we go, why should we be worried about this kind of breaches? I'll give you some examples of where breaches are happening. But what is happening with this is that we are now connected towards ubiquitous computing. Okay? So we have our smartwatches, which is collecting the data, we have our smartphone, which is collecting the data, and they're all somehow interconnected. So to access my bank, I use some of you might be using your Apple watches, and there is a possibility to authenticate yourself. Okay? And then you have the bank IDs, the mobile IDs where you're just enrolling yourself with your face and your fingerprint image. Then they can talk to the bank systems in the back end. I just use the name of a bank, which is DNB, which is a bank like SBI in India, but you get the idea that it could be any other, right? And then what is distinct here is that rest of the things remain same, except the capital. Right? Now we have this bank system, and then the data that is stored on the bank system is constant across all different bank systems, across all different government systems. In the case in India, Aadhaar card also has the third-party integrations. Right? So if you are a company, you are trying to invest in or you are trying to provide solutions which is based on biometric authentication, I think they have opened up the third-party APIs, which means you can query to the Aadhaar card details. For the moment, I think it's only the government agencies, but maybe the day will come when it will also be opened up for other private sectors. Okay, so now what the idea here is that everything that we used to do offline on the big devices, big bulky computers, is now transferred to the mobile, right? So which creates a new kind of opportunity, at the same time a new kind of challenge. And what could be the challenge here? So if you look at this one, now as soon as the advantage is that now you don't really have to carry your credit cards anymore. All you need to carry is that you need to carry your iPhone, your Android, whatever the device that you're using, and all the cards are integrated into that, right? So now there are two problems. One, your biometric data on the phone is remaining, and your personal private information, which is credit card information, your bank details, everything is available. So if your phone gets compromised, you're losing both of these data at the same time, right? And of course, there are mechanisms where people use what they call it as trusted environment. Arif is sitting here, Arif is working on trusted environment. So if you know about trusted environment, it's a place where you do not really have access to the general public, only some specific software can get access to that environment. Right? It's like a small shell within the operating system. Okay? So that is one way you can protect. That is one way where you can compute all the information. But then if you look at a bigger picture, all those components that we have, they have these attacks. Yesterday, I showed you the alternative representation of this. It is exactly similar to this one. Now you see a pipeline. You see a biometric data that is captured here, and I showed you here that could be a presentation attack. And then I showed you that once the image is captured, there is a quality estimation happening, which I'll talk about in the next part of the lecture. So this quality estimation happens here, and once the quality estimation is happening, if you are satisfied, it will be sent to the enrollment database. Right? This is your Aadhaar card database, for instance. And then you have the comparison module, and then you have the decision module, whatever is coming out here. Now, in the ISO IC 37, the document also talks about all possible attacks. One of the attacks is this here. You can attack and inject. The other attack is here. And the third attack is at the enrollment database. And then you have the other attacks which can happen at the comparison level, score flipping level here, or the decision outcome, right? Multiple attacks. But the breaches, as I told you, is mostly concerned about the storage subsystem. So before we go there, let's try to understand what is happening. So I don't know how many of you actually read the news, but there was a breach in the Aadhaar card database. The data of number of millions of people were losing. And the worst thing here is that we do not know how many people have been compromised. There is only an estimate. And this is not only the case of India. So many years ago, there was a big breach in South America. So fingerprint database got leaked. And the problem with the biometrics is that we only have one biometric, right? So if I lose my face, then I can't really replace my face. If I lose my fingerprints, then I can't really replace them. Right? But with the other ones, maybe if your signature gets leaked, you can learn a new signature, right? But not with the face. So the biometric modalities which are physics, which are physiological based, can be very tricky to recover back. So this is one of the examples where Aadhaar card data got breached, and the story goes. When I was reading the article yesterday, I also kind of figured out it was not the breach of the database, and in the sense of database was not compromised, but it was somebody who was a third-party vendor. He or she was selling the data. Right? You have this multiple enrollment centers in Aadhaar card. So every city had an enrollment center, and it was given out to third-party vendor. And these some of the third-party vendors did not really take care of this data privacy. It was just shared with us. Right? Now, what should we also consider about this privacy aspect? If you think about this, I told you one motivation we cannot really replace the biometric data. And the second part is that there is regulation. There is regulation like GDPR Act in European Union, which is called General Data Protection Regulation. And then there is the AI Act, which came into force a year ago. This has been worked since 2019 or 2016, and now it has been finalized. And what I learned recently was also that India is launching another act called as DPDP Act. Anybody has heard about this? So it's a privacy act again from Indian government, and there is a task force that is working very actively on making sure that the data of people are not compromised. Yeah. So there is an aspect of this privacy. So people are kind of concerned about how to secure it. And now comes the challenges when we are talking about the securing of this data. Let's take the very first challenge. The very first challenge is that you have a person, and then what you do is that you kind of extract this image, whatever that could be, either deep learning, classical machine learning, anything, and then you get a feature descriptor, which is typically a bunch of numbers. And it's a vector of numbers. Now, as soon as I have this one, what should be the first property of this system is that I should not be able to go back from this feature space back to the image. Right? Because once I have extracted the feature, it should be bijective, which means it goes only one way, and you should not be able to come the reverse way. Now, the classical approaches here is that some of you might have learned about hashing. You have learned about hashing, right? It's a one-way encryption. So you can do the one-way encryption, but then hashing has its own problems. Hashing has the properties of collision, so which means that two feature vectors of two different people might be colliding. That means I'll not be able to make addition whether it's person A or person B. Make sense? Okay. So this is the challenge number one. Now we should not be able to go back from feature space back to the image space. And then if you happen to go there, what should I be able to do? Immediately I should be able to create new set of stuff. Which means if I know that my database of let's say the Jabalpur University here, it's compromised, and then I can't go to every single student and ask, okay, can you come back again to capture it? Because I need to create new template. Maybe it's possible in the university setting because we're talking about 30,000 people. Now scale it up for a bigger population. Scale it up for the Indian population of 1.3 billion and scale it up for the world population, right? It's very expensive process. So what should we be able to do? We should be able to immediately replace these features without even involving the user, right? So this is the second motivation. And then comes the third motivation. Now, most of our face, if you are using multiple systems, our face is recognized, our face is registered in SBI bank accounts for the sake of some example. And then maybe it's also registered with another bank account where the entire service is connected. So it's like there is a third party vendor, let's say your Paytm or your other service providers who are actually using the space image. And then addition to that, you might have another bank where you're also registered. So most of the people have it that way, right? So some people have it, their salary account connected to one bank, and then they have a home loan account connected to another bank. So you have multiple systems, but all of them are using the same biometric data. Okay. So as soon as I have this, so what happens is that I'll be able to deduce the information from two different banks. I do not know who that person is, but I'll be able to tell if that person is a customer in both banks or both systems. So what should I want? I want the place where I should not be able to link those two banks, right? I should not be able to deduce the information that he is connected to that bank and this bank or any other service. So if I'm just looking at the a biometric system, what do I want? I look at it from a very bird's view approach, and then I say that two images, any reference, any group, I extract the features, and then I compare them, and I say yes or no. Now, what is the problem in such a kind of system is that there is no unlinkability, which means I can still connect two people who connect one person across two different services. That is what we call as linkability. And then there is the second aspect, which is called irreversibility, which is the first example that I showed you. I have the feature space. I should not be able to go back to the image space. Okay? So that is reversibility. And then the moment I know that the database has been compromised, I should be able to revoke the data. Revoke the data in the sense that I should be able to replace the template without involving the user. Yeah? Because it's very expensive, as I discussed. So what do we want? So we want a system where it is most of the current systems, if you do not enforce template protection, they will be reversible, they will be linkable, so across two different banks, and they are irrevocable, right? So what we want from that system is to go towards the next system where there should be irreversibility, there should be unlinkability, and there should be revocability. Three big properties, right? So these are the ones that we are concerned about. So I'll show you some example on how, when, and why we do. If we achieve everything in a right manner, so what we are doing is we are going away from that feature extraction comparator to something that's in the red line towards something that is in the green. So we keep the feature extractor as it is because I don't want to go back and train a new CNN for extracting the features. I extract the features as the CNN provides me. And on top of that, I can start working on protecting the template. Right? So if I achieve everything in the right manner, I would be following the green line, and then I'd be able to achieve three properties, which is unlinkability, reversibility, revocability. Right? Now we know that as soon as I try fiddling with the feature extraction, there will be some drop in performance. This is understandable. At the cost of security, I lose some performance. Now, how we manage and how we balance it out is something that I'll show in the next set of slides. But at this point of time, everybody is kind of with me on the idea that we should not really keep the templates as plain templates, but rather than protected them, right? You could go for very simple mechanisms such as hashing, or you can just do a key-based protection, encryptions. But then there are some limitations and there are some shortcomings that will not allow us to do that in real time. Okay. Okay. So let's start about this biometric features, right? So before we go there, we want to understand what is feature, what is template. So a feature, I'll let you read this one later on, but there is a vocabulary document where everything is described. They clearly distinguish what a feature is, what a template is, what is a protected template, so that you can read it later on. I'll give you a visual illustration here. So anything that I have in the image space that I can identify a person, whether it's face, iris images, ocular images, so that is typically called as reference images or biometric sample, right? So that could be a raw fingerprint. And what is this? This is nothing but the features which are typically extracted after a certain amount of processing. And this processing could be mathematically grounded, this could be based on deep learning, this could be handcrafted features, and so on. It could be anything, right? So the idea here is that if I give you just this image, you'll not be able to tell who this person. If you know that person, maybe you'll be able to recognize to some extent this one, but still it's quite challenging, right? So we are talking about millions of people. Okay, so here, if you get an idea of what images and the features, now templates is exactly the features that we are talking about here. So these are our features, right? In the other words, it's also templates. So that's why we call it as template protection. So we are protecting those features, not the images itself. Okay. All right. So what is the problem now? If I'm able to do this, in the previous case, I showed this is feature, this is feature. So this already looks quite good, right? But then what is the problem? The problem is, even before the deep learning came, there have been a number of works that have been proposed. So you have an original face, and you do some kind of feature transformation, and then you get this templates. Now, if I am able to learn something very, very nicely, I can learn an inverse function of this, which means from this image, I can go back to this image. Yeah. So now, of course, you might tell me that, okay, the quality of the image is not really good, but it's just a matter of fine-tuning the algorithm, retraining the algorithm until you get the high quality image. So we have this deappearance where we are creating a template, and then the inverse function of that is reappearance, where I can match the face LBP from this one. Again, this was the work that was already done in 2016. And now, why is this more relevant now for us? Now, in this week, last week, you also had a very nice lecture from Professor Ojha talking about generative AI, where she introduced you the visual of variation autoencoders and GAN networks. Now replace this inverse function with such a nice network here. So what do I need to do? I take a bunch of templates that are stored in the database, which are protected, and then I dump it into a encoder space, and then I learn a representation, and I'll be able to create the image. So from this image, this is X, and X dash is the variant of this, so I can learn this whole mechanism, right? So GenAI, whatever we are talking about now, it also has an implication of the security practices in our case. Now, let's go to the next part. So you might now tell that, well, maybe face is not the best idea. So we also learned about fingerprint. I'll use fingerprint. Fair enough. If you do that, so what happens in this case? Another work which was done in 2015, Professor Jain and his group. So they showed that if you have a minutia pair, then you can recreate the fingerprint. You all remember the minutia points that we were talking about, X, Y, and theta. And this is nothing but a bunch of points, right? So I have a set of points here. And from the set of points, I can use my creativity, and then I can start creating the samples infinite number of times. And at some point of time, these samples that I've created will be very close to the actual image. So here you see that if you have the impression 1, this is nothing but for fingerprint 1 and fingerprint 2. So the scores, the comparison scores are here. fingerprint 1 with R1 is 54, and then with F1 with R4 is 312. R4 is this one, and this looks very close to this one, right? So what did I need? I did not really need any knowledge about this as the system. I can start picking random minutia and then start creating the fingerprint until it starts attacking one of the images in the database. Right? You have to think about the scale here. Now, what if you don't have the minutia points? Another extreme condition. So this minutia point could also be randomly guessed. Right? I can simply take a blank paper and then start putting some dots and then say, okay, these are my minutia, start creating something. Now, if you're thinking about millions of people that are in the fingerprint database, at least one of them will be matching, right? So then you just keep on repeating this over and over. Okay. So there is another problem with the template creation from random minutia. So face is vulnerable, fingerprint is vulnerable. And then yesterday I was also looking into understanding what is happening recently. Again comes the derivative AI networks, right? This is a very recent paper which has been put on archive a couple of months ago. Not even a couple of months, I think it's a couple of weeks in fact. And here the idea is again the same, right? So whatever we were doing here, very manually, guessing the minutia and then trying to reconstruct it from minutia points to the images. So they have used the generative adversarial networks, which is typically unit-based architecture. And then they dump into the network a couple of minutia points. This is the red and green. And from that, they learn this mapping. Now you can already see that there is a discriminator here. There is a generator here. They have discriminator generator. So using this, I'm now able to create the fake fingerprints, which they call it as proxy prints. But the idea is that there is a translation happening with the template image space. And they also go one step ahead. And what do they do from the one step ahead process is that they create the sample and they don't stop there. They create fake samples of it. So they show a very nice process where they're creating the mold here. You see that thin film layer. And on top of that, they're inserting the thing. So at this point of time, your fingerprint, whatever you're getting here, is quite realistic. And this could be a benefit of doubt that the quality is slightly lower. So I'll accept it. And if you put it back into the system, it will be accurate. And here you see the score, right? You see the score 107, 73, 56, 56, and so on. So for every comparison they are making with the fake fingerprint and the real fingerprint, it's now becoming more and more difficult. So we established that the face has a problem, then we went to fingerprint, and even fingerprint there is a problem here. And then they not only stop at in the recent work that has been played here, that has been published here, they don't just stop at showing that fact. It is just shown, they just don't show the generative adversarial networks, but then they also show that in addition to that, they can create a mechanism where it can be protected. So that's what they call it as proxy fingerprint, right? So you have an enrollment sample 1A and then authentication sample 1B, which is XI and XJ. So whenever you capture, you do an encoding, and then they introduce a key mechanism, and the key will align the template. And once the key is aligned, so then they're putting it into the third-party backend, so whatever the database that is. And now, even if the attacker is trying to steal some data, so whatever the information that they're getting here will not be exactly matching the template. So you can see that here, it is not matched. Maybe it is stolen fingerprint that is detected, but in the other case, it is correctly. So the idea here is that they introduce this sub-module, which is actually quite smart, because in the first case, they use the encoder-decoder generated adversarial network for generative adversarial network to create the fingerprint, fake samples, and they use the same mechanism with some key insertion in the middle so that it becomes stronger, so that it becomes privacy preserved. Okay, good. So then this is one way where we can resolve the problem. And then we have the other modality, right? So we also discussed about this idea of iris recognition. I did not really get some time to talk about that, but as we have some time today, so I can discuss slightly about that. So what is happening here? So if I have on the top part, you see a bit of binary codes. They're nothing but some zeros and ones, right? So if I have that binary codes, zeros and ones, even if I don't have, if I can guess them randomly, from there I can create this circular images. Okay, I put a black dot here, and then around that I wrap it. It's nothing but a cylindrical rectangular to cylindrical transformation, right? So I'm taking it and then making it a circle. So I take a random binary code and then I make the iris. And once I have the iris, what I can do is I can simply insert this random opening of the eye around. Is an idea? So everything here comes down to again random guessing. And then there is a bit of learning in going from that second row to the third row and fourth row, but still it's possible. Now you can also imagine that if I just insert a GAN network here, so I can learn, or the autoencoder network, whatever is your favorite, you can learn the mapping from this one to this one, right? So as soon as I do that, then you can recreate the whole face. Even the iris recognition systems are vulnerable. So fingerprint is problematic, iris is problematic, also face is problematic. And now why this can be a problem? So if you just look into the iris images, I'll just show you how things actually work. So this is how typical iris recognition system works. So what we do is that we extract the image between the iris outside, iris and pupil and iris. This area between the red and the blue region, between the blue and red region. And then we know that we don't want to deal with the noise. So we kind of also find out the region of the eyelid and then the information, which is an intersection of all these three areas. So this area, and this area, right? So we eliminate this part. So what we are doing is that we are using a very small, tiny amount of information from iris. And this tiny amount of information will give us the binary code. And this binary code is a starting point. So I'm inverting it back. Okay. And then, of course, there are other kind of attacks, there are other kind of problems. So if you're wearing a contact lens, then the images become, what do you say? They have the potential to attack the system. Even worse when you have colored contact lenses. So for those of you who do go for these costume parties or Halloween parties, you get this fancy the contact lenses, which can be extremely dark, or you can have some kind of patterns of cat's iris or so on. So those are all coming against the. So even if you don't consider those things, even if we assume that we collected high quality iris data, but the templates are a bit of a set of binary codes. And if I have a binary code, I can do all this reverse transformation. Okay. So what do we need to do? We need to protect them, right? So now we know that anything that we are not protected can be reversed back into the original space, and they will not respect the properties of linkability, reversibility, and revocability. So what can we do? We can think about some approaches. And in a survey that was written in 2017, there has been discussion about a number of different approaches, and there they talk about some of the things here. Cancelable biometrics, I already told we have Professor Khanna sitting here who has been working on this. And then we have biometric crypto systems, again, she has been working on that. And what has come recently in the field is that homomorphic encryption. I'll not be able to cover that completely, but I'll give you a brief introduction to what it is. I'll talk a bit about the irreversible transformation in the rest of the talk, but you can extend the idea for other kind of applications. Okay. So what is cancelable biometrics? So if I just assume that I have okay, let's take a bit of time here to discuss about all these aspects. So if I have a biometric template, it could be single or it could be multiple, right? My system could have only one fingerprint, or it could have 10 fingerprints, or it could have face, fingerprint, and iris. Right? It could be multiple things. So irrespective of that, what I can do is I can do some kind of transformations that is completely irreversible. And there are a number of works. If you read that paper, you can see that what works are talking about them. And then there is also this sorting. Sorting is also the technique that is used in password protection. So what is sorting? So if you just assume that you have a plate in your hand, and then if you're trying to put the salt, there is no way that you can reproduce 2 times the same mechanism of putting the salt, right? It's very random process. So which is exactly the case here. So we take the biometric data and then we sort it. Sorting is nothing but it's adding some random knowledge to the data. And then you have the other category, which are called as biometric crypto system. So we talk about the idea of taking a biometric sample, and from the biometric sample, you try to generate a key. So if I'm generating a key from my own samples, it will be more unique than somebody else, right? So that is the idea. So you can generate a key, and then that key should match all the time you're coming back to verify yourself. Now, what is the problem there? Anybody can think of any problem in the key generation schemes? Particular algorithm dependency is there.
Sharing of key is possible.
Sharing of key is also possible, yeah. And then the other problem?
Data breach. Data breach.
Data breaches, yeah. Wow, how can the data breaches happen?
Multiple entry.
For instance, if you take the face, which we talk about the mask, right? So mask is still the same face. Now, if you're using face to generate the keys, then it doesn't distinguish between whether it's a real face or it's a mask face, because face is what is going to create the keys, right? So that is a problem. And then there is also the key binding, which means you don't trust the biometric sample to generate the key, but you say that, okay, I will manage the key for you, and then I'll give one key for each. This is a nice solution, but then somebody has to be responsible to manage all the keys. And how do I trust if it's a third party? So if it's the government, maybe I will trust them. Okay, they will manage the keys. But if it's a third party, I really do not know if the key they have given to me can be shared with somebody. Right. So there is 2 other mechanisms, which is key binding and key generation, which is another set of the intersection of cryptography and intersection of biometrics. Right. And then we have the other idea, right? The other idea here is that you forget about everything else. You just encrypt the data, and then you never go back to the original data. So you do all of your comparisons in the higher dimension space or lower dimension space, however you want to predict it, right? So it's nothing but now I have a name, let's say Manvi. Manvi becomes ABCDE, and then my comparison happens in that ABCDE, not in the Manvi space anymore. So you understand the idea here? So we transform the data from encryption to go upwards. And then there is also this idea of garbled circuits. Garbled circuits introduce some amount of randomness, right? You take a simple data and then first you do a homomorphic encryption and then you use garbled circuits on top of that. So that is again another theory. Here is a very interesting area for some of you who might be planning to take up some works in this direction. These homomorphic encryptions are very computation heavy, right? Now, if I ask you to wait 10 minutes to verify you, it will not be very happy. So what is happening in the recent years is that there have been new techniques which are coming up, and these techniques are focused on faster comparison homomorphic space. And second one is what is called as somewhat homomorphic encryption. It's the algorithms are SHE. It's not fully homomorphic, but it's somewhat homomorphic, right? So this is another area that people are investing in. And then recently there has been some works on fast indexing for homomorphic encryption. I think there is a patent that has been recently applied for that from some of our colleagues. What they're trying to do is that transform the entire template into homomorphic encryption. And then this serves 2 purposes: to protect the data and at the same time to do fast indexing and search, right? So if you have 1 million database and if I go and tell I'm Kira, it has to go through 1 million entries. So how can you make it more efficient for searching the database queries? So that is another application of that. Okay, so we'll not be able to cover all of these things, but you get an idea of what homomorphic encryption, garbled circuits, at least garbled circuits can go and read stuff. And there is also alternative part to this, which is called as zero knowledge proof. ZKP. Yeah. So you have been working on that. You know that, right? I think Arif also is working somewhat on this one. So the idea here is that I do not really ask you that whether you are Manvi, but I ask you to prove that you are Manvi. Right? So I do not need any data from you, but I'll tell you, okay, what is 2 plus 2? And then you will give me an answer in a particular space. So this is typically the zero knowledge proof, right? So I do not ask you to share the data. So that is another area which is quite interesting. And I'll just take an example of how we can use some of the existing techniques for creating this kind of protected templates. Let's start with a simple approach. There is this mechanism called as bloom filter. The idea here is that if you take an iris template, right, it's a binary code. I told you it's zeros and ones. If I have a bunch of zeros and ones, what I can do is I can divide them into a number of blocks, and then from each block, I can treat it as one word. Right? So I take the whole chunk, and then I represent it as a bird, as a block, and the block has some properties. So it has to be certain width and certain number of bits. And then if I take each of them, what I can do is I can take another column here, another column here. Now I can do a simple XOR. So what does XOR tell you? It gives you that representation, right? One with 0, 0 with 1, 1 with 1, and 0 with 0. So when I do this, I can go from binary space back to the real space. So simply, it's nothing but binary to hexa conversion, right? So I have 21 and 26. If I do XOR with these two, I'll get a new number. Now, without doing any key here, anybody who knows XOR can reverse it. XOR is reversible, right? It's a basic property. That means to make sure that this is protected, so what I do is I insert a key which is very specific to the application. So then I say, if you're using SBI Bank, then the key is 20. But if you're using HDFC Bank, then the key can be 50. Okay? You kind of insert specific keys. When you insert the specific key, you have two representations, then XOR with the key, you get two representations again. And you kind of do the process over and over again. So what happens here is that the previous input that was 0 and 0 now becomes 1 and 1, which means if I do all that's not true. So what happens here is that now you see that the answer is 39 and answer is 40. So you go to that particular bucket and then you set the indexes of zeros to 1 and 1 because these two are activated. Right? So it's a simple process. It's a very easy process to make that alignment representation because in iris recognition, you don't really care about the alignment. And then this scales up very well to that particular problem. Now, this is one way. And then there are some challenges in this case, right? So the number of challenges here is that I speak about how many bits, what is the block size, what is the length of that, and so on. So if I look at the problem, if I increase the number of bits, the intra-class variance also kind of grows with the size of each block. Right? And then if I increase the number of words, then I start colliding, which is a common problem with hashing as well. From hashing, if two people have the same name, then the chances of even if the last name is different, if I do a hash, there is a very high collision rate between those two because the words are the same. So what can we do? And then there is also this other problem, right? Which is now n sequence, which is kind of goes with irreversibility and another problem. So what can I do? This was another work that was done some time ago, and the idea here is that going away from single filtering to multiple filtering. So about this bird cuckoo. So it never lays eggs in its own nest, right? It goes and lays in somebody else's nest, and then when the bird is up, it comes and takes the bird. So the idea was explored in databases where they said instead of using one single bucket, I use multiple buckets. And then I only fill the second bucket when I'm full with first bucket. And the idea here is that if you take 4, if I were to insert 4 there, then I take a hash of, let's say, one hash mechanism, which gives me a result of 7. And the second one gives me a result of 8. And then I go and fill that particular units. So 7, now hash of 1 is 7. So I insert 7 there. And then again 8, I insert it there, and so on. Now, if I keep on doing this, I can make sure that the false positive rate, or if what you see in the bottom part, FAP, is kind of also increasing, right? It's going from 0 to 15%, 31%, and so on. Now take the same idea, then start inserting multiple buckets now. You say, okay, I take the first one, okay, this, it is already filled. So what I do, because it's already filled, I go set in the next bucket. So you kind of initiate multiple buckets, and at some point of time, when the buckets are all filled, you'll be able to get a good template. For instance, in the first part, you had this 62%, and finally you are getting 1.15%. The error rate decreases. Again, this is a very well-known idea in database management. So if you've worked on databases, indexing, in the classical computer science sense, right? So it's exactly filling up all the entries. So you fill up the entries in a systematic manner. So you can take a look at this one later when you get the slides. But the idea is very simple, right? We are extending the ideas of Bloom filter. We are just introducing some 2 different buckets. I say, okay, I have bucket number 1, which is a hash function, h1 of x. And then I have second one, the index 2, which is a combination of hash of first one and the hash of second. Then I set the values depending on what I get output. If it's 1, I set it as 1. If it's 0, I set it as 0. By doing that, what you can see is that one, the number of bits that you use per item for achieve epsilon could be as it increases, the target false positive probability also increases. But then if you try to decrease this one, the number of bits also kind of so what in the original paper, what they showed is that if you have approximately 7.2 bits, then you are guaranteed to get around 3% false positivity, which is quite good, right? So we use this idea, and then the problem in the iris is like, okay, it was a nice idea to say, okay, Bloom filter has some problems. I can insert the keys, but managing keys is a problem. So I can use the second approach, which is cuckoo filters. And if I do the cuckoo filters, you see, first of all, the iris varies across all different captives. So when I'm giving my iris image, maybe I'm opening my eyes completely, so then I don't have the noise. Second time I'm closing it slightly, and the third time maybe there is a light reflection from the ambient light. And every time I do, there is a variation in the data. So from this variation, I should be able to get one stable feature, right? That comes up with another problem. So the idea here is that we try to see, okay, what is stable? Now, if you look at this one, you see that some area of the iris image is stable, right? And then there is also some information which is discriminable. So if I look at that one, now take the same area. This is very different from this image, this image, this image. One, it should remain stable. Second, it should also be remain discriminable from the other people's iris. So if I can do that, so then I'll be able to create a better map. So what you can do is you can do this class-based learning. So I have a number of samples of iris images. Then I can say I learn a meta image. Meta image is nothing but one image that represents the whole of the database. That I can do, right? Because I've collected the database already. And then I can only learn the representation. And then I create this meta codes, which are nothing but the iris code, the gamma filtering code. And then I can say, okay, those are all the iris images. Those are all the bits which are stable across all the classes. Stable as in stable for every single one of us. And then I can also create the other one, which is discriminable for each of us. So how much is my information different from your information, right? So then I have 2 maps. So once I have 2 maps, it's easy to create 2 buckets, right? So I create bucket from one and the second one from the second bucket. Then if I go back to the original diagram that I showed you, what we want to achieve is we want to achieve from simple feature extraction to proposed the data protection system. And in this case, the idea becomes like this. So you have an iris image, and then you extract the stable code, you extract the discriminable code, and then you do a cuckoo filtering, whatever, the bloom filtering, whatever you would like. And then once I get this two new QR codes. So now I have two new QR codes. What can I do? I can simply join them together, or I can do one more XOR on that, or I can try to interleave them. So what I can do is I can introduce one more layer of XOR here, which kind of says, okay, first bit and first bit, second bit and second bit, and so on. So by doing a simple transformation here, I'm able to get a template that is more safe. Okay, so let's now take a look at this one, right? So if you think that, okay, this is actually this slide should be updated here. But the idea here is that if you do not want to do all this processing manually, what you can also do is you can introduce some networks there. So the first network does some kind of processing and we get one feature. The second one does another set of processing, and then I get the code there. Then once I have that, rest of the block remains same. So the idea here is that instead of doing all manual processing, you can also do the processing using the deep networks. Okay, I also introduced some figure here compared to the previous one. In the practical set, what you can do is that now that you have two buckets, you can also use two secrets. Right? So this secret is again 50 and 26 in our case, but you get the idea. If I want more stronger system, at the cost of having more keys, I can get better performance. All right, so I'll not show so much of this, but just to give you an idea, a real system which is without any protection is here. It's very close to 0% accuracy, but the moment you introduce this kind of protection, you see that the performance goes up. So the error rate is from approximately 0.1% to it goes up to 1%. So it's like a increase in the equilibrium rate. Right? So the idea here is not to tell you that do not do that, but also to tell you that be prepared to lose some information, some accuracy when you do the protection. Right? So you have to make a trade-off between them. Okay, I'll not show you this one, but just to give an idea. So as soon as I've created this template, what I also want is that I want to make sure that they're not unlinkable. How can I say they're unlinkable? If I take the samples and then I try to establish the genuine comparison, so that means Kiran versus Kiran, A versus A, B versus B. So you get a cluster which is different, right? Compared to Kiran versus A, Kiran versus B. That is the other part. So I have two different graphs, two different distributions. So in this case, if I am taking two different systems, one from SBI and from HDFC, and then if I try to match each one against each other, then both of them should overlap very significantly. Right? So if they overlap very significantly, what can I tell? I cannot tell if that person is in the database or not. So then you do this linkability study. In the unlinkability study, you see that, okay, it should be almost zero. But here also you can see some amount of problem. Although I say that it's very good, you can see in this area, I can easily conclude that maybe the person who's in that database and this database, if he has gotten a score of 0.2, it's likely that he is present in both tables. Okay? So what ideally you would have two distributions that overlap completely. Okay. Now this is a bit of a more detailed overview. I know that we'll not be able to cover everything, but I just wanted to give you an idea of how you can prevent the database breaches. Okay, any questions on this part? So I'll introduce some small amount of cryptography here in this case. Any questions on this so far?
We had this on
Two questions. Okay, I can take yours first and like.
there were three problems, right? So third one was that we don't want to disturb the user again and again.
Right.
So how do we like, or we have I don't understand how are we?
Revocability, right? Okay, so I'll talk about the revocability in a moment. Your question was?
Sir, what if the user is failing a lens while registering a template?
Yes, so that's when you do the presentation attack detection, right?
Yes, sir.
So wearing a lens, if you remember the first figure I showed you, we have the
Yeah.
capture part. So that's where you introduce the mechanism to stop the lens.
So a proxy can be created while wearing the lens.
Yes. If you do not have a presentation attack detection,
Hmm.
then you can get through the contact lens.
Sensor cannot specify that.
Sensor is not typically enabled, but you have to introduce an algorithm to know that, right? Or you can use some multispectral sensors which have inherent capability of detecting the contact lens. Okay, revocability. So how do we do the revocability? In this case, we simply, if I just take the example of this one, right? So what can I do? I do not have to call the user again. What I simply do is I simply replace this secret 50 and 26 with 90 and 8. Right? So, but again, if I do that, what I should also understand is that I should go back and measure the performance like this one. So I introduce a new key and then try to measure if they are stable or not. Right? So that is why I don't have to call the user back to give me the error concern. It's like one-way hashing, right? You're introducing a new hashing mechanism, and the user is not involved in this key. Okay. Okay, I'll just talk a bit about another idea. This was another work done by one of our master students, and the idea here is that most of you might be knowing this randomness chaotic maps, and I'll show you how the chaotic maps work. Let's just simply take this one, right? If I have a particular random seed, and then I keep on spreading it randomly, you see that the process is very divergent, right? So anytime I have a seed from here, I can end up in any of this space, which creates kind of infinite number of opportunities for me. So once I have that, if I choose, for example, if I want to generate the key itself. Now, in the previous case, we were generating the keys differently. In this case, if I generate the key itself here, so that key can be using this simple mechanism, which is completely random. And again, I don't know how much time I have.
We have 50.
We have time. Okay, so quick. Good. So here.
5 minutes.
Okay. Okay. So 5 more minutes.
Yeah, but
5 more minutes. Okay. Okay. So I just want to give you an idea. So this is also quite interesting because of the fact that most of you might be knowing about quantum computing, right? So this is going to be a big surge in the next couple of years, and people are investing on it. And here the idea is that you take use of some kind of mathematically formed formulas. For instance, you have elliptic field, any random field, right? You describe that with the equation y square equals x to the power of 3 plus bx plus c, and in certain assumptions where the p is following certain rules, q is following certain rules. And with this, what you can do is you can start playing with the equation and then just try to, I'll share the slide so you can read it through, but I just want to give you an idea here. So if you solve the equation, I'll not go through all this thing, but I'll just skip here. And here I can show you. So I start with the simple iris code, and then I create a binary number from the map. So this could be systematic, it could be random, depending on the rules that you make. And from that, I can repeatedly run through the sigma to follow that particular equation. And this will give me a new binary number. Okay, so from that new binary number, what I can do is I could also take the same idea on top part, and the second part I can create an initial point on the elliptic curve. This elliptic curve is something that I define for the entire database. Right? If I'm a bank, State Bank of India, I have my own equation. This could be public. So there is no problem in having this as public. The only thing that is not public is PNQ, right? So it will be public private keys. So many of you might have read about this Diffie-Hellman algorithm. Yeah. And there is also this RSA algorithm. So there is the idea of public and private keys, right? So it's the same idea that we are going to use here. And then I can create an elliptic curve, and then I select a random subject, and then I try to XOR with the original subject, basic mathematical operation. And then I use it to obtain the number z, and then z is used to determine the x point in the coordinate of the elliptic curve. Right? So once I have that, I have the key that I need, I have the other constructs that I need, so I can create a new template. If this is more confusing, just remember it's also there is other kind of equations that like salsa, which are called as again, salsa has a number of variants. In this case, take 4 blocks, so IA, IB, IC, and ID. And then what I do is I take the IA and then I shift it by 7 times, left shifting, and then I add that information into this IB. So now one block is contributing to secure the second block, right? And now we can say that, okay, what if this gets compromised? Now it can cascade everywhere. So then I introduce the third block IC, which is again shifted by 9 times and get a new block, and then shifted by 13 times, I get a new block. Okay, so the idea here is that you are interleaving the information. So if one block gets compromised, then many other blocks might not be passed. And again, this algorithm is not our algorithm, right? It's a very proven algorithm from cryptographic field. So we simply take that one and then we try to introduce into the iris space here. Now, the idea here is that the whole block remains as it was before. So you have this XOR block. So you remember this figure. So we had 21, 26, and the key was there. And then I introduced 2 new features, and then I get this 1 and 2, right? So now what I can do is I can just simply use the same idea and then put in the salsa algorithm that I have. Instead of just doing a simple XOR, I'm introducing a relationship between them. Gives an idea. So don't be so much confused about how everything is working that you can read it up later on, but get the general idea. The general idea here is that we are not introducing anything extremely complex, but we are making use of public elliptic curves. And from the elliptic curves, we are trying to generate the keys, and the key is derived from multiple samples of the iris blocks or multiple blocks of the iris sample. Okay. And if you do that, again, you have the same matrix, right? So you have this, remember the iris system was somewhere here before, and now the moment I introduce the protection, so I see that the error rate goes up slightly. And at the same time, what is also interesting is that the false match rate is decreasing because of the way I'm dealing with the templates. But false non-match rate is increasing slightly. Right, so you can lose some performance in X and Y in neither of this direction, but now you see the overlap that I was discussing is so much better. There's a good overlap, which means that if I have the samples from my SBI Bank and HDFC Bank, if I cross match them, I'll not be able to tell which one is in both databases. Okay. And additionally, you might also be interested in finding out what happens by doing across multiple data sets. Not just 2 data sets, but multiple data sets. In that case, you also see that the distribution is quite different. So the attack and the original non-matrix samples, which is let's say Manvi with Suhas and Suhas with Manvi, these 2 comparisons, they end up in this region, which is exactly where the attacks are also ending up. So which means I am not able to tell if it is a genuine user or if it's a attack subject. Okay, so this is I'll just end the call with one small thing. There is another idea which is for the Gen AI. So most of you might be using this metaverse. I don't know how many of you use it, but you use this AR VR headset from Facebook, right? So the idea is to create this avatar, and you have a physical, so you have a virtual presence in the metaverse field. So what happens if I create, instead of stealing the actual biometric, if I steal your avatar? So there is a very recent work. I was looking at this from University of Autonomous Madrid. very well-known biometric group. So they have studied this problem and they are showing that how it can be impacted. So the idea here is that on the top side, you see that you have a real ID, and then from the real ID, you create an avatar. Right? For me, as a user in the metaverse, I get an ID. I get an appearance. And if that avatar is stolen, and then I can inject the voice into that. So I have an avatar plus my voice, which enables me to interact in the virtual system. So I can go into your Facebook and then I can say that I'm Manmi, and then I can start interacting with the system. Here's an idea, right? So now here the idea is that the first they show how easy it is, or how it can be done. So you have a driver video, you have a target image, and then what you're doing is that you are trying to transfer everything from this one into this image. So this avatar, this person, whatever is here, can be easily recreated. This is understandable, right? We have learned about the deepfakes. We have seen that video generation is not a problem, so we can create such kind of avatars. And once that is stolen, what you can do is you can come back to the mechanism that we were looking yesterday. You remember we spoke about deepfake detection using the landmark key points. And if I have the landmark key points, I can also construct some 3D graphs, triangle graphs. Yeah, the dynamic triangulation. So now I can look at the deformation between the different landmarks. Here is a very dense landmark. Here is a sparse landmark, 68 landmarks here. This is, I think it's 468 or 512 landmarks. 468 from MTC, right? Yes. From MediaPi. Yeah. The number of landmarks that you're using, based on that, you can create this dense triangulation. And using the triangulation, I can see across each frame, how much is it varying. It's like it's a group of frames, right? If I have 30 frames, then I can measure the difference between them. And now comes the interesting idea. So since I'm putting them as a graph, so I can use this graph convolution neural networks, right? By using the graph convolution neural networks, they extract the features. And then because I have number of frames across different video sequences, I can introduce temporal attention pooling. So instead of regular attention that we were talking about yesterday, just highlighting the eye region, just highlighting the nose region. Now what we're highlighting is that we are highlighting the entire sequence, right? By taking into account the temporal attention. So just by doing that, they also show that, okay, if you do not have any protection, any kind of protection for that avatars, your system will fail. But just by introducing this approach, they're able to get the accuracy back up here, right? So the idea is, say here again, just to tell you that the Gen AI avatars is also vulnerable for attacks, and there have been some recent work that are doing in this that have been done in this direction. So this work is also available on archive. So I'll post the slides and then you can just share the link. And they also show some different kind of settings in the paper. They show how the clips can vary, how the performance actually varies across different frames, which you can read it up later. And then there is also another recent work from recently published in TIPS, Transactions of Information Forensics and Security. And they've also come up with a very nice method. And here it's a combination of crypto and your avatars. Okay? So what they do is that, okay, I have an avatar, I have two avatars, and then I have a mutual authentication between them in the metaverse domain, A and B. But this is based on the physical world. In the physical world, they also introduce the concept of blockchain in that. So you have a player and you have another player, second one here. So the player registers to the system. And when it registers to the system, there is a token issued by the blockchain. And the same thing is updated here. So that way, this remains secure, right? So if this remains secure, this also remains secure. So they introduced this very nice protocol. I did not really have time to read the protocol in detail, but if you look at that, it's based on challenge response, right? You remember I told about this, I do not really need to know who that person is, as long as you can prove me that you are the person you are claiming to be. Right? It's almost like zero knowledge, right? So that is the same idea here. So they take the virtual ID and then they claim, okay, this is me. And then on the other side, the avatar B will just challenge the person. Tell me what is 2 plus 2 in Jabalpur. Right? You are asking in a particular space. Right? And then the person responds back with the response. And here they introduce something very smartly. So they take the iris image from the HMD devices because your VR lenses, they can capture the iris images. You cannot capture the whole field because of the way it is mounted, but you can always get your iris image. So once you get your iris image, what you can do is you can extract the iris code, which is nothing but the binary code that we were talking about. And then from there, you create a number of different responses, and then you put them in this construction, which is a combination of multiple parameters. And from here, you're going to say, okay, this is my response, right? So it is as simple as asking somebody in a particular domain. So if I ask you what is 2 plus 2, it is everywhere it's 4. But if you have some rules, let's say 2 plus 2 is 3 in Jabalpur and 2 plus 2 is 5 in Indore. Then if I ask you what is it in Indore, then your answer should be 5. Okay, I'm giving a very simple example, but it's slightly more advanced than that. But you get the idea that GenAI also has this problem with the avatars and then metaverse world. Okay, so that is what I was planning to talk about today. So these slides I will put it, then you can read it, and then what are the upcoming fields. But then remember that GenAI also has impacts. So the only way to protect the biometric data is to make sure that you have better template protection mechanisms. So Professor Khanna has been working on a number of different techniques in this direction. So if you are interested in working with her on template protection, she will be the right person to talk to. All right. So I took 5 minutes extra today. So we can probably now break for the coffee and then come back and start with the ethical implications of GenAI. Right? Thank you.